All right, let's do another few examples on solving exponential equations. We talked before about that principle of equality where if we can get the bases to be the same, then our exponent should be the same. So let's do a few more of those. If you look at example number 2, and it asks us to solve, and we have an exponential equation because we have our variable up in the exponent. This time we have 8 to the x equals 4. Now remember, I want to get my bases to be the same. So on this one, I have a base of 8 and a base of 4, and they're definitely not the same. And I need to figure out how I can get them to be the same. Now we need to be careful. Some students are going to want to try to maybe divide or something like that, like if I tried to divide 8 by 2. The problem is, if we're doing that, we have to divide both sides by 2, and then our bases still won't be the same. Plus, when we do our order of operations, we have to make sure that we exponent before we divide, and because we don't know what our exponent is, we have to be careful with division. So the only thing we can do is try to rewrite this into the same base. Now if I'm looking at 8 and I want to try to get it to be a 4, 4 to the first power is 4, and 4 to the second power is 16. That's a little too high, right? So what can we do instead? Well, maybe we need to break it down smaller than 4. Maybe I can take 8 and 4 and break them both down. So what numbers does 4 break down to? Well, I can break 4 down into 2 times 2. So I can say that 4 is the same thing as 2 squared. Could I take 8 and maybe break it down to a bunch of 2s so I can get the bases to be the same? I know that 8 breaks down into 2 and 4. I know that 4 breaks down into 2 and 2. Oh, look at that. I have 1, 2, 3 2s. So instead of calling it 8 to the x, I can really call it 2 cubed to the x. Isn't that the same thing as 8? And when I'm raising to a power the 2 cubed to the x power, do you remember when I'm raising to a power what the two exponents do? Yeah, they multiply. So I can really say that I have 2 to the 3x is equal to 2 squared. And now what do you notice? The bases are the same, right? And as soon as my bases are the same, then I can say that my exponents should be the same. They should be equal. So I can make a new equation that says 3x is equal to 2. I can divide both sides by 3, and I ended up getting x equals 2/3. So on this one, I had to change both bases to get them to be the same, not just one. Let's do another one. Look at B. I have exponential equations, exponents, variables and exponents actually on both sides this time, but my bases aren't the same. So I need you to figure out what we can change 16 into and 64 into so that they have the same base. What about 4? I can say that 4 squared is the same thing as 16. And I can also say that 4 cubed is the same thing as 64. Remember, when I'm raising to a power, these exponents multiply. And now that my bases are the same, I should be able to just set the exponents equal to each other. So I can say that 2 times 2x plus 1 is equal to 3 times x plus 3. As soon as I got these bases to both be 4s, then I can set the exponents equal. All right, let's continue solving. I'm going to distribute the 2 and I'm going to distribute the 3. The next step I did is I subtracted 3 to both sides. And I subtracted 2 to both sides. I subtracted a 3x to both sides is what I should have said. And then I subtracted 2 to both sides. And I ended up getting x equals 7. Again, you can always plug in 7 to your original equation and make sure that it works. Make sure that the left side absolutely equals the right side so you know you got the right answer. All right, let's do a few more in this video. Maybe you can try these. Maybe you could pause the video and see if you can get your bases to be the same. Then set your exponents equal and solve for x and see if we get the same answer. All right, for part C, I noticed that my bases were 9 and 27. And I know that 9 can break down into 3 and 3, so I'm going to say 3 squared is the same thing as 9. And I know that 27 is the same thing as 3 cubed. Now that I have my bases equal, I should be able to set the exponents equal. So I have a 2 times 2x and a 2 times negative 8. You notice that I distributed that already. I also am going to distribute the 3 through, so I got a 3x minus 12. I'm going to solve for x by subtracting 3x to both sides and then adding 16 to both sides. And I ended up getting x equals 4. Hopefully you got the same thing I did. All right, let's look at D. I notice that the base on the left side is 8, but the base on my right side is a 64. And so I want to get them to be the same base. Well, hey, I know that 8 squared is really the same thing as 64, isn't it? So I can take that 64, I can change it to an 8 squared. I haven't changed my problem at all. I've just written it in a different form. But now that my bases are the same, I know that my exponents are the same, and I can say that 4x plus 2 is equal to 2. I can subtract 2 to both sides. I can divide by 4, and I ended up getting x equals 0. Let's make sure that that's the right answer. So if I plug in 0 here, I have 8 to the 4 times 0 plus 2, and hopefully that equals 64. Well, 4 times 0 is 0, 0 plus 2 is 2, and 8 squared is, in fact, 64, so I know I got the right answer. Hopefully you did too.